So in addition to the unit I just showed you with the semi-automatic welding, which really is the majority of what we'll go after in the market, we're also applying the unit to automated welding, and in particular robotic welding. So you can see the FANUC 120i arm here, and if you look closely, you can see how we routed a hose. This is an 1.5-inch hose, and we routed it to a custom designed 3D printed housing that's built around the specific dimensions of the robotic torch. The one thing we don't want to do, at least right now, is get into making our own torch. We have our own torch for the semi-automatic welding, but with robotics, usually the customer already has the system in, it's programmed to make parts. We don't want to go in and have them change the torch and then have to reprogram everything. So we build around the torch that they have. They have a torch, it's tested, it works well for them. We don't want to upset that apple cart. So we build around that specific torch if possible. And we target 150 CFM here at the torch, and we're able to capture the fumes upwards of 350, 400 amps, which generally with robotics, you're gonna weld a lot more aggressively, you're gonna weld longer, you're gonna weld more frequent, and you're gonna weld more aggressive, where by hand, we might be welding 280 to 300 amps with a robot. You might do the job with 350, even upwards of 400 amps, even higher sometimes. Really depends on the welding application. But again, here's our fume shroud around the welding torch. This is a Tragascus, I believe a G2 style torch. I may be wrong about that, but and then you can see our hose routes down and to the front of this unit. So Mr. Baumgartner is going to make a weld for us. A lot of customers, a lot of companies will use water-cooled torches. I'm not telling them not to use water-cooled torches, but this will do, it will help a lot with as far as keeping that torch cooler. So we have several systems out now that are applying to robots. The beauty is a lot of robots will have like a hood over it, and they'll allow the smoke to come up. By capturing the fume here, it'll keep the robot cleaner. You won't need to put the hood over the system, so now you let shop light in so you can see inside the weld booth a lot better rather than enclosing it under a hood and then ducting that air out. In a typical robot application, we might move 2,000 or 3,000 CFM to capture the fume in a robot cell, whereas we're only running 150 CFM with this to capture that. So generally speaking, in the long term, once everything's finalized, we think that it'll be a lot more economical way to capture weld fumes for robotic welding as versus just using a static hood and dust collector system. So, and we're using it with the new FV 190 SC unit. So it's giving us the pressure we need and the airflows we need to be able to do it on the robot. So it's pretty cool.